The NASA is confirmed. An ancient wanderer from deep space has altered its path, and a world in our own solar system is now directly in its sights. For the first time, humanity may witness a collision between an object born around another star and a major planet. Data from the most powerful space telescope ever built has upended all prior projections for the interstellar visitor known as 3I. Initially cataloged as just another transient passerby, meticulous long-term tracking has now exposed a profound anomaly in its journey through our solar system. This isn't a simple hyperbolic arc. Its course is actively changing. The James Webb Space Telescope's unparalleled sensitivity was key to this discovery. While ground-based observatories and other orbital assets saw nothing amiss, Webb's infrared instruments detected minute but consistent deviations in the object's motion. These deviations defied the standard models of celestial mechanics that govern every other asteroid and comet. The change is small, but over the vast distances of space, it compounds into a monumental shift in destiny. Multiple analytical teams across different agencies have verified the data, ruling out instrument error. The verdict is unanimous. 3I/ATLAS is being steered. The question is, by what? And where is it being steered to? The answer points toward the rust-colored plains of Mars. This object is a relic unlike any we've studied before. It carries the chemical signature of a stellar environment entirely alien to our own. Spectroscopic data reveals a bizarre amalgamation of materials. Dark, carbon-rich organic compounds are interlaced with brilliant metallic alloys that reflect sunlight in strange patterns. Its thermal emissions are inconsistent, flaring and fading in a way that suggests a complex, porous interior actively interacting with solar radiation. It is neither a simple icy comet nor a rocky asteroid. It is something entirely new, a previously unclassified type of interstellar debris. Does its unique physical structure hold the clue to its unexpected navigation? The scientific community is now divided between profound concern and unprecedented excitement. A direct impact on Mars is a very real possibility. Simulations show the object intersecting the planet's orbital lane within an extraordinarily narrow window, leaving little room for a miss. If it strikes, the energy release would be cataclysmic. It would instantaneously excavate a crater dozens of kilometers wide, hurling subsurface material high into the thin atmosphere and triggering planet-wide seismic echoes. Yet, from this chaos would come a golden age of discovery. For planetary geologists, the impact would act as the ultimate natural drill, exposing deep crustal layers and potentially subterranean ice deposits that have been hidden for billions of years. Astrobiologists view it as a chance to search for biosignatures in freshly ejected material, far from the sterilized surface. Most tantalizing of all, fragments of the impacting body itself, pristine matter from another star system, would be scattered across the Martian surface, offering a direct sample of galactic building blocks we could never retrieve by mission alone. The event would transform Mars into a unique scientific laboratory. Every orbiter and rover would become a frontline observer. Seismometers would map the planet's internal structure with clarity never before possible. Cameras would document the evolving dust storms and atmospheric changes. This real-time planetary experiment would rewrite textbooks across multiple fields of science. However, our preparedness for this event faces a sudden, critical challenge. Our primary sentinel at Mars, the MAVEN orbiter, has fallen silent. This spacecraft, crucial for analyzing the Martian atmosphere and any changes from the approaching object, entered an unexpected safe mode and communications have failed to reestablish. Teams are working tirelessly, but its loss would blind us to a key dimension of this historic event. The race is on to regain our eyes on the sky, as the interstellar object continues its unwavering approach. This situation forces a paradigm shift in how we view our cosmic neighborhood. We can no longer think of our solar system as a closed, predictable family of planets. The interstellar medium is active, sending material across the light years, and now we see it can deliver that material not just as a fleeting glimpse, but as a direct participant in planetary evolution. We are living in a moment that blurs the line between celestial observation and celestial event. To follow every update on this developing story, make sure to like this video and subscribe to the Winds of Thought channel. The universe is presenting us with a front row seat to history. What do you hope we discover? Share your thoughts below. This is a scientific warning unlike any other. A piece of another star system is not just visiting ours. It's on a final approach that will scar the surface of Mars forever. The interstellar object designated 3I/ATLAS is rewriting the rules of celestial mechanics before our eyes. What was first calculated as a graceful hyperbolic flyby has transformed into a direct intercept course. Data from the James Webb Space Telescope, possessing sensitivity beyond any Earth-based observatory, has confirmed the irreversible change in its trajectory. The numbers no longer lie. Its path is leading it into a devastating gravitational embrace with the red planet. But why is this happening, and what does it mean for our understanding of the cosmos? The most startling revelation isn't just the destination, but the object's utterly alien nature. Webb's spectroscopic eyes have dissected its light, revealing composition that defies our solar system's catalog. It is a cosmic mosaic. Dark organic tars are splattered across surfaces of brilliant, reflective metal. This isn't a simple ball of ice or rock. It's a relic forged under conditions we can only theorize about, carrying within it the raw chemistry of a distant stellar nursery. What secrets about planetary birth are locked inside this ancient messenger? For Mars, this represents both catastrophe and the ultimate scientific gift. The planet, already marked by ancient scars like the Hellas Basin, is about to receive a fresh wound of interstellar origin. The kinetic energy of the impact will be apocalyptic, instantly vaporizing rock and blasting a new fiery crater into the crust. Yet, from this violence comes an unparalleled opportunity. For the first time in history, we will watch a planet's deep interior be excavated by natural forces. Layers that have been buried for billions of years, potentially hiding traces of ancient water or even clues to a lost magnetic field, will be vomited onto the surface. This transforms Mars into a spontaneous open-air laboratory. Every robotic explorer we have there will become a frontline witness. Orbiters will analyze the composition of the towering plume. Rovers could, in time, examine freshly exposed bedrock. Most profound of all, fragments of the impactor itself. Pristine material from another star will be scattered across the landscape, offering us our first tangible samples of the galaxy's building blocks without ever leaving our solar system. Are we prepared to collect this priceless interstellar debris? The potential for discovery extends to the very possibility of life. The tremendous heat and pressure of the impact could create temporary hydrothermal systems in the Martian subsurface, where liquid water might pool amidst mineral-rich soups. On a young Earth, such environments are thought to have been cradles for early chemistry. While no one expects life to spark from this single event, astrobiologists see it as a chance to observe the complex organic reactions that form life's preliminary steps, unfolding in real time on another world. We are not just observing an impact. We are witnessing a new chapter in a planet's biography. However, seizing this scientific bonanza hinges on our ability to watch it happen. Here, we face a critical obstacle. Our primary sentinel at Mars, a key orbiter, has recently entered an unexplained safe mode, its voice falling silent. Engineering teams are racing against the clock, but its vital instruments hang in the balance. Will we face this historic moment partially blinded, or can we restore our eyes in the sky in time? The global scientific community is mobilizing with unprecedented speed. Mission planners are performing delicate orbital dances with aging spacecraft, conserving precious fuel to position them for the perfect view. There's even talk of deploying microprobes from orbiters to fly through the ejecta plume, gathering direct data on the shockwave and composition. This event forces a monumental shift in perspective. We can no longer view our solar system as an isolated island. The galaxy is dynamic and its debris, the cast-off pieces of other planetary systems. Cannon does cross the void to literally leave its mark on our neighbors. The geological history of planets is interwoven with these interstellar visitors. This collision will be a permanent monument to that fact, a crater that will preserve a record of both the impact and the exotic chemistry of the impactor for millions of years to come. It also serves as a stark, practical lesson for planetary defense. While 3I/8LS targets Mars, not Earth, its high velocity and unpredictable nature highlight a vulnerability. Our current defense strategies are built for local asteroids and comets. How would we respond if the next interstellar visitor had our own world in its sights? Observing this Martian impact will provide crucial data for answering that terrifying question. Ultimately, this is about more than rocks crashing in the dark. It is a profound moment of cosmic connection. An object that began its journey around a star that died before human civilization began is now concluding its billion-year voyage by colliding with a world we are actively studying. We are the first intelligent beings in our solar system's history positioned to comprehend such an event, to learn from it, and to let it reshape our understanding of our place in a vast, interactive galaxy.
If you want to follow every development of this unprecedented interstellar event, make sure to like this video and subscribe to Wines of Thought. The countdown has begun. What do you hope we discover in the Martian debris? Let us know in the comments.